Hello, on the bench today we have another valve amplifier, the second one from the same person, and this is a Leak Stereo 20, so it's a stereo 20 watts a channel amplifier, and it's in pretty bad condition. If we have a look around, as you can see, those are rotten, they need replacing. Those are, well, not worth talking about those, they'll need replacing. And there's no valves at all, but they aren't too hard to get. I was looking around on the internet, and Cricklewood Electronics are still in business. First bought stuff off of them probably 35 years ago, and they're still going, and they've got all the valves in stock, and it uses two EL84s in each output stage, left and right, and two ECC83s in each stage as well. But there's a major problem with this amplifier. Oh, before I get on to that, I've also got the matching preamp here. I'll just find that. So there's the matching preamp, which plugs in to the power amplifier and gets all its voltages from that. But this is also fairly awful. Again, no valves, and I've already been poking around and checking capacitors. They're all hopeless, the capacitors, old electrolytics, and whatever these things are, 0.1 microfarads, they all test bad. The resistors ain't too bad on this one, but what I want to do is forget that for the time being, because I want to get the power amplifier working before I even think about the preamp. That's a bit sad, isn't it? But it's the voltage selector. So I've tested the two speaker output transformers as best I can by feeding a signal into the outputs and then measuring on the primary of the transformer, which goes to the valve, and in theory they test out fine. You stick in a few volts here and you get a lot more out the primary, but how they would respond at the full operating voltage of the valves, I don't know. Only time will tell. But the major problem with this thing is, which is more serious than anything, is the mains transformer. I measured the primary resistance, and I was getting fluctuating reading between 4 and 12 ohms, and couldn't really find out why I was getting that. It just seemed like there's an intermittent somewhere. Thought it was the main selector on the top, but that wasn't it. So in the end I desoldered it completely from underneath, removed it from the chassis, and then these end plates come off quite easily and you can get access to the wiring inside. And when I saw what was inside it, it was quite horrifying. It was obviously overheated, the windings were slightly charred, the voltage selecting wires going up to this select thing up here, plug up there, they were melted together. So I hadn't given up complete hope on it. I managed to pull the wires apart that go up to the voltage selection connections, and then I was getting a more consistent reading then of 12 ohms constantly. But it still, I didn't like the look of the charred windings. It really looked a bit hopeless. But I thought, you know, I'll stick some voltage on it, a low voltage, onto the primary and see what I get out of the secondary before I stick full mains on it. But before I did any of that, I thought I put it back in the chassis and I wired it all up again, and I thought I'll test the insulation resistance between the chassis, in other words earth, and the primary using my insulation tester, which is what electricians use for house wiring testing. And then I put it on 250 volts, the insulation tester, between live or the primary winding anyway, and earth, and I was getting a very low resistance. At low voltages with a normal meter it was testing fine, but with 250 volts on it, it was reading certainly maybe a few k ohms, so there was obviously leakage to earth, and that would have blown the earth leakage trip if I put mains on it. Simple as that. So that transformer's had it. It's scrap. You could get it rewired maybe, but that would cost a hell of a lot of money, and to buy new ones for this that would be, not new ones but second hand ones, would be fairly hard to find, and if you could find one, I think it would be very expensive. So I'm going with plan B, which is a bit of an odd one because it won't be original. What I intend to do is use this, which is a mains inverter supplied to me by the guy who owns the amplifier. It's a 12 volts to 230 volts inverter. And what I intend to do, well, I've already tested it, is rectify the output and smooth it. And I've already tested this, and you get exactly the right voltage for the HT, which is 325 volts. So that in theory will mean that this thing will have to run on 12 volts, in which case it's gonna draw a fair amount of current off the 12 volt supply. I did a rough calculation. I think it's going to be around 7-8 amps off 12 volts, but he doesn't seem too bothered about that at the moment, but it's all experimental. That takes care of the HT. The valve heaters, which of course are 6.3, don't need the rectifier valve, obviously, that's 5 volt heater, don't need that, but what I can do, because these are 6.3 volt, I can wire each pair of valves in series and run them on 12 volt. Same goes for the ECC 83s, for the back here ECC 83s. Series them up, the pairs of valves, to run on 12 volt, and I think that should work really. I worked it all out from the valve data, and the heaters alone will take 2.5 amps for the power amplifier and the preamplifier combined, which is a fair bit of current, but I don't know what else to do when there's no easy way to get a transformer. I think it would be a fairly cheap way of getting around this problem, but in the meantime I've got the long and very tedious process of, and let me just turn it over, look at the bottom of the chassis. I've got to go through all trying to escape all the resistors and check their values are okay. All the electrolytics will need changing, and these things, which are I think 0.1s, and there's one over there which I'm not sure of. Some nice little polyesters there, they'll be fine. And of course these canned capacitors, believe it or not, you can still get them again from Cricklewood Electronics. They're 32 plus 32 microfarad. so I can get replacements, and they're not terribly expensive. I think they're around six or £8 each, and that would be nice to keep it some originality in the actual amplifier itself, if not in the power supply. So what I'll be doing is I've got to feed in the voltage through this connector. Well, I can't use this connector because these bulging plugs that go into there, if you can find them on eBay, they're charging something around £25 or £30 just for a plug, which is utterly ridiculous. So I'm going to have to replace that with an IEC plug. I think that's the best idea for that. IEC socket, I mean. And then feed in the HT and earth 0 volts and plus 12 into that socket. That'll be coming out the inverter box here, which will also have the rectifier in it for the HT. So that's my next stage now, is to go through all the components and check them out, make a long list, and then get the parts ordered. So continuing with this project, which I don't really want to do, to be honest. It's a lot of hard work basically, but yeah, the idea of running it on 12 volts, it's not absolutely wonderful, is it? And it's going to draw a hell of a lot of current. The inverter's going to draw a fair bit, so even doing that, it's going to be an expensive project. I've gone through all the resistors, all the capacitors. All the resistors are out of tolerance, the capacitors are all rotten crap. So including the valves and even these CAN capacitors you can get now, 32 plus 32, so that'll be good to keep those original. But the total cost of components, including valves for this, comes out around £150, which I guess is okay if you like that sort of thing, as these are fetching quite high amounts on eBay, or people are charging high amounts for them, these amplifiers. But it would have been nice to keep it as mains. So, problem is to get the right transformer. I can forget the rectifier duct valve, because I can put a solid state rectifier in it, that's not a problem. Okay, I may have to alter the resistor, dropper resistors in the in here, because the rectifier valve drops a fair bit of voltage compared to a solid state rectifier. That's not a problem. So I was looking around on eBay trying to find a transformer that might suit this, and I did come across one. I think it was 230 volt output, single HT winding, which is fine with the bridge rectifier, and 6.3 volt at about 4.4 amps I think it was, which I think would just about run this. But of course the price was through the roof. I think they wanted 130 for this transformer, brand new, toroidal. But of course they know why you want it, they know it's for a valve thing, so they jack the price up, don't they? So I went to sort of another plan. I found out this little electronics shop in Cheltenham, which is about 15 miles from here. It's been around years. I first went in there in 1979. I'm amazed it still exists, but it does. Explain what I wanted. Have they got any old valve transformers in there, mains transformers? He said, what do you want it for? I said, it's for a Leak Stereo 20. He seemed to know exactly about those and what I needed. He said, oh yeah, you'll have a real trouble getting one of those. He said, no, we haven't got anything like that. but he was very interested in what I was trying to do. So that was the end of that one. Didn't really think they would have one in that shop, although they've got all sorts of old junk in there. So I phoned up the owner of this amplifier to see what he wanted to do. And I think we're going to go with the 12 volt option at the moment with the inverter, and then if that works, you can think about maybe buying the toroidal transformer to stick in it, because that would be the best solution really. But then you're looking at a total cost overall of refurbishing this thing just for parts of close to £300. Well, I wouldn't spend £300 on this thing. I don't particularly like it. It's only 20 watts a channel, but I know they're very collectible and whatever. So that's where I'm at the moment. I've got to order parts from RS and Brickwood Electronics. Oh yeah, and before I forget, having done all the work on this thing, I've still got no guarantee it's going to work. The speaker transformers have not been tested at high voltage. That would come off the valve. So if they got problems, then we're doomed. Right, while I'm waiting for parts to come, I'm going to pull out one of these rotten old capacitors and see how bad they are, because these could be serious. They could. They're the coupling from the ECC83 anode to the grid on the EL84. So if they've gone leaky, they're going to stick a certain amount of DC up the grid of the EL84, which is not going to do it any good at all. And it doesn't want to come out, does it? Bloody things. That's it, got it. Right. Don't know what sort it is. It looks like an electrolytic, but I'm pretty sure it's not. But whatever it is, I'm going to measure it first of all. See what capacitance it reads. It's supposed to be a 0.25, it measures 0.33. Okay. Right, now I'm going to stick it on the insulation tester. And what I'm going to do is stick 250 volts on it, because it's rated at 350, isn't it? Yeah, 350. So let's see what it does, and press test. I'll stick in 250 volts on the capacitor, and that is basically the resistance at that voltage, 5 megohm, which is not awful, but I think it would be enough to not do the valve any good, because valves have got high impedance, haven't they, on their grids. Oh well, just a little thing to try. So I'll go back to waiting for components, although I did get these things, which are rather lovely, to go on the speaker sockets. In fact, they're almost too nice to put on there, but only problem is I pulled one out this end and the hole is much too big for this. So that's another job I've got to do, which I could have done without. I've got to take this plastic insulator off and make a new one. I could even make one out of metal. That might be easier. So I think I'll probably have a go at doing that next. Okay, that took nearly an hour. Just doing the speaker terminals on both sides and fitting an IEC plug into the chassis, and next step, get the new components in when they come. Okay, well, I've been waiting for parts to turn up, which they now have. I've been making a bit of progress on this thing. Got rid of the old maze transformer. That was enormously heavy, and it was such a hassle having to keep lifting it up and down. And he can have that back with the amplifier if he wants to keep it, try and find another one, whatever. Made a nice blanking plate up out of the top of an old DVD recorder. I find they're quite useful, nice, easy to cut sheet steel, and they're quite useful. So apart from that, that's the old connections for the transformer, which I've sleeved with heat shrink so they can go back on a new transformer if one ever does appear, but we shall see. Anyway, and I placed the order for the resistors and capacitors with RS and the valves with Cricklewood Electronics about 2 o'clock in the afternoon yesterday. And would you believe it, what turned up? 9 o'clock this morning, a parcel from Cricklewood Electronics. I think that's a pretty impressive service. Less than 24-hour delivery. They must be working all night on stuff like this. But what we got in here, we got some nice can capacitors, 32 plus 32, 500 volts. Got 2 of those. And we've got some valves. And here is an ECC 83. And I haven't looked inside, but I know what a valve. I used to smash these when I was a kid. We had an old electric organ in the attic when we moved into the house. I took it apart with my father because it was too heavy to get down in one piece. I took all the valves out and shot them with an air rifle. Loads and loads of EC83s and whatever. And it's made in the Slovak Republic, would you believe? I didn't know the Slovaks made valves, but well, there we are. I thought it was just Chinese these days that made valves, but well, I don't know what quality is like, but we shall see. And what else we got? We've got some EL84s, electro harmonics, nice little face on there. Don't know who the hell they are. I've never heard of them. Electro harmonics. And this one's made in Russia. I didn't know the Russians still made valves, so that's interesting. And apart from that, I've got a massive bag here from RS, which has just arrived. So again, very good service, less than 24 hours. And I've got to go for all these bloody resistors and capacitors and try and sort them all out into their values. But never mind, it gives me something to do. The weather's really crap today. Very heavy rain, so I've got plenty to do in the workshop. So look at all these parts I've got, all these components, all individual whatever packaging. Not only that, they had to come in individual paper bags as well, which I think's a bit bloody ridiculous. And not only that, because I bought some solder wick, I've got I don't know how many pages of rubbish about safety on it. Well, I'll go straight in the bin, won't it? Just ridiculous. All this stuff on safety. Ah, well. So here we are, several hours later. All the resistors and all the capacitors have been replaced, except for these. These were fine. Didn't bother with it, replacing those. Nice new filter capacitors are in. And I don't know how many yards of solder wick I used, but just as well I bought some more. Not a job I enjoy doing, and I must admit I'm not completely happy with it, because the modern resistors and to a degree capacitors just haven't got long enough legs on them, so I had to sort of join bits of wire on, which doesn't make it look too tidy, but I didn't know what else to do with it. It's just the way it goes, I guess. Resistors legs are not as long as they used to be, but that's about as good as I can get it, I think. Now I've just got to wait a little bit more to get some wire, because I've got loads of scrappy bits of wire here, but I want some decent wire to wire it up with. and then I'll start going about modifying it so that it will work on 12 volts. The valve heaters will have to go in series, as I said earlier, and well, we'll get around to that later. So we've got to the point where this thing is nearly ready for testing. I'm using the IEC socket, and I know this is dodgy as hell because it's a mains socket and you could plug mains into this, but the guy who wants this done, he wants it done like this, so he's going to get it done like this, and he's not stupid. He knows that not to plug mains into it. So that's going to be the plus 12, which will come from the inverter, and in turn from the battery. And the earth pin is earth 0 volts for HT and 12 volts, or hopefully a bit more than 12 volts. And then the HT goes out on the live pin of the IEC socket for the fuse, and onto the HT point, which is just before that resistor and the filter network. And then what I've done on the 12 volt side is I've put a tag strip down there, and you get the plus 12 coming in, and it's sent off to the various valves. And I'm running the two EL84s in both sides, heaters in series. Same on the other side, two EL84s, heaters in series. But I discovered something interesting about ECC 83s. They have a dual filament, which is either wired in parallel for 6.3 volt or series for 12 volt. So that made things a fair bit easier. So the next stage of this thing to do now is I'm going to stick some stick the valves in it, then stick 12 volts or a bit more, maybe 13, because I think I'll get a bit of volts drop. But anyway, stick about 13 volts on it, see if the valves warm up, make sure they all warm up, and then if they all warm up, I'll plug in the inverter, and hopefully it'll work. But I ain't got much confidence. Not much confidence for this thing. Mainly worrying about the speaker output transformers, but we shall see. I'll go ahead and put valves in it anyway. So all the valves are in, and I've got just 12 volts connected at the moment to my power supply, which is up there, and I've got 12.6 volts and a current limit of 3.3 amps. So I'll just turn it on and see what happens. Okay, obviously they draw more current when they're cold, valves, and yep, we're dropping down. I estimated that it would be 2 amps. Well, estimate, I added all the currents up and it came to around 2 amps. So that is interesting. I've got more or less 2 amps. So that looks fairly good. And I'm running on 12.6 volts, and you probably won't be able to see, but I can see they are glowing. Yeah, that one's definitely glowing, and that one's glowing. Back again. That's glowing. That's glowing. They're all glowing, they're all lit up, fine. Now I want to know, I'd be interested to see what I get on the actual voltages on the pins, without damaging the valves, that is. So, that's where I got my power supply connected. What should I do, pick one at random? ECC 83. Oh yeah, I'm getting 12 volts, you can't see the meter, but I'm getting 12 volts on the ECC83, so I'm losing about 0.6 volts in my cable. And I'll go for where's the EL84? That one there. I'm getting 6 volts on the EL84. Okay, sounds reasonable. I think I'm going to need a bit more than 12 volts though, ideally, to make this work properly. But that was fairly successful anyway. So I think now the only thing left to do is to, dare I say it, plug in the bloody inverter. I would ideally like to have something that I could vary the HT on. I might actually, what I might do, where the HT comes in there, I might stick another resistor. That's 100 ohm. If I stick something like another, I don't know, 100 ohm on there, just to have a lower HT to start with. Okay, well I'll try and wire that up. Okay, here goes. Instead of the 100 ohm, I'm using two 470s in parallel, just for testing, off the HT input to the capacitor. And I'm all ready to turn the power supply on, and I've got a signal going into it which says 90 millivolts at 1 kilohertz. Got no load on it, on the speakers outputs, and it's now drawing. Well, let's have a look at the power supply. I've got them in parallel, the two power supplies, so I'm running at 13.5 volts, and the metering, you have to add the two currents together to get what it's drawing. So it's drawing at the moment 4 amps with no load on it, but I've got a signal going into it. I'm just going to stick my scope on the negative and then the one channel output, and I've got nothing. Why have I got nothing? Why have I got nothing? It's tripping into current limit for some reason. Right. So now the damn thing's working. It seems to have a mind of its own. It's producing a signal from both channels, and this is the channel that was bad before, and although it's producing a signal and no load on it at the moment, no 8 ohms, it's got distortion on that channel, and that channel will occasionally just disappear for no reason at all. And not only that, the bloody inverter's unreliable. It trips out for no reason whatsoever, so I'm not happy with this solution. It needs a proper mains transformer in it to make it reliable, because as soon as I try and do any testing to find out why the left channel drops out, and it's not an intermittent, I've banged it, I've hit it, I've thumped it, I've used an insulated pen, and nothing makes any difference. But if I turn it the other way up, the whole chassis, it'll probably start working on that channel. So my conclusions are, at the moment, I need a transformer for it, but I don't think I'd be happy paying £120 for a new transformer, because this inverter situation's a bit of a disaster. The only thing I can possibly think of that's causing this channel to go out occasionally is the speaker output transformer. So what I might do later, if I can be bothered, because it's a lot of hassle, is swap the two transformers over. Right, here we are, another day on, and I think I've actually made some progress at last. I actually swapped the two output transformers, speaker output transformers, and would you believe it, the good channel was still good and the bad channel was still bad. So it isn't the output transformers, which is extremely good news, but this thing was so unpredictable. Even touching my scope, my multimeter lead onto the connections would cause the bad channel to start working, although not working very well. So it's just the capacitance of the multimeter leads, or the resistance to earth, whatever. So I was totally mystified by this, and I was getting to the point where I was going to disconnect all the wiring around the side and get the bloody board out, because I suspected the wiring underneath. Well, as it turns out, it is the wiring underneath, because if we look at the circuit diagram, when it will focus, and I can't see very well looking through the camera, but we've got a point here where the cathodes are connected to earth via two 270 ohm resistors. Well, they are, there's no problem with that, but what isn't connected to that point there is these two 470Ks, which is connected via wiring on the back. So basically that 470 was floating in mid-air and not pulling that point down. Same with that one, and I can demonstrate that now. If I go onto the that is the junction point. Those two 470s should be connected to the two 270s at this point, and trying to do all this at once. It's difficult. Look at the meter, 70 something mega ohms and floating around. So there's a bad connection on that joint. So if I go over to the other part of the other channel, to the same point, well, when I can hold the bloody thing on. These old connections are so badly tarnished, that's why it's poor connections. 0.3 ohms anyway. So I'm going to solder a link on top and see if that makes the bloody thing work. Right then, put that link in and it works perfectly. And I'm so bloody happy that I fixed the bloody thing. So I was dreading having to take the board out. So I put my generator on, over to the scope, and we have two perfect sine waves. Well, more or less perfect. It's getting a bit close to clipping. And because I've got low HT, I've only got 273 volts off the inverter. I should get at that point 325 volts, so the power is going to be down quite a bit, but it's working. That's the main thing, and with a decent transformer in it, it would work fine. If I go up to the audio analyzer, which I've set to read watts, 8.7 watts, which, as I said, would go up considerably. Could check its distortion. This is at 1 kilohertz, by the way, at AC level, and distortion is 1.3%, close to clipping. If I turn the input signal down a bit, yeah, that's much better now, 1%, and down again, a bit more, a bit less power input, 0.7%. I think that's fairly good. I think that's where I'm going to end this video, because I really want the guy who owns this to buy a decent transformer for it, if he wants it to work properly, a mains transformer. And I know it's 120 quid, but it's really the only way to go. This inverter idea is a joke really, so I think I'm just going to have this as a part one, and hopefully he'll let me buy a transformer for it. But a lot of good's come out of it, this project. I've learned a hell of a lot about valves. I don't normally work on valve stuff, so thanks for watching. Give me a thumbs up. I'm just so pleased I got it working. Bye for now.